Hey everyone, welcome back to another video. In this one we're going to look at creating a digital keypad with a password code in it that we can use to communicate with other actors. So if you haven't seen the previous video, this is essentially a part 2, although it's not exactly. So you don't have to go back to watch it, but I recommend watching this video, which I'll have linked in the description for you before attempting this one, as we cover some of the concepts with blueprint interfaces and event dispatchers. So the reason that I'm making this video is had this discussion over in Discord this morning about somebody trying to create, specifically Kai, trying to create a digital keypad for their game. And it's kind of overcomplicated, to put it bluntly. We can see here that they've got each individual number to a point with blueprint interfaces, and then we've got custom events with delays and check passcodes and pretty much a bunch of interfaces. And then when we look at the buttons, this is what their code looks like for each button and their components list. So what I'm going to do is I'm going to show you how to essentially remove all of this, clean it right up, make it reusable and modular so you can use it with different actors. So you can essentially just duplicate the blueprint around the level and have as many keypads as you want with different codes and that kind of thing. So what we're going to do is we're going to go into the template that I created in the first video. So all this has, and all that is set up, is in the blueprints for the first person character, is we have a widget interaction, and then we've got a interface, essentially an input action set up to do press pointer key and release pointer key. So if I jump in, this is what we're using for this red dot, and that allows me to interact with widgets within the level. So we're going to create something similar. So first thing we need to do is go to UMG. I've created a folder already called Digital Keypad. And in here, we're going to start by creating a widget blueprint. We're going to call this WBP underscore digital keypad and then button. Because what we're going to do is we're going to reuse this for all of the buttons in the project, or in this code. So the first thing we're going to do is we're going to drag in a button, bring in a text, and then we're going to rename these. So for the button, I'm going to just call this btn underscore button, should be fine for that. And then for the text, we want just number, should be okay for this. Cool, I'll make it a little bit bigger. You can always play around with the design and style afterwards. And now in the event graph, what we want to do is delete event construct and event tick, and we're going to actually use event preconstruct to set our button text. So as you can see, we can't see the variable here. That's because in the designer for text, I didn't set it to is variable. So now if we go back to the graph, I can get access to that, and then we can drag that in as a get and then do set text. And we specifically want set text brackets text. Cool. So preconstruct, and now we can promote this to a variable. However, what we want is an integer because we're going to be passing in a number, and we can't promote that from here. So we're going to create a new variable, and we're going to call this number, or we'll do this as display number. We'll change this to an integer, and then we can drag this in and connect it to our in text, and it will automatically convert it for us. And now that we have this, we can make our button do something for us. So what we're going to do is we're going to use an event dispatcher to tell the blueprint or the owner, the parent, what number's being pressed. And we're going to do that by going to btn button, doing onPressed, so we get a click event. And then for the display number, we're going to get that. And what we want to do is we want to create an event dispatcher, and then we'll call this button pressed. Should be fine. And then for inputs, we want to make sure that we have an integer value. Button number. Then we're going to drag this in, do call, and plug that in like so. And then we can have this. So when we press the button, it gets the display number and it sends that through to the other actor, which will be listening to this. So that's it for the button. And what we're going to do is we're going to create a new widget. So user interface, widget blueprint, and then widget blueprint underscore, what did I have the other one? Keypad. Might as well keep it up with my notes. And in here, I have a canvas panel that allows us to position stuff. So we can put our content in here, followed by a vertical box. And we do this so we can change the order of the keypad around. So we're going to make this centered. And then I typically do 0, 0, 1920 by 1080. And then change the alignment to 2.5. And this just makes it line up better with 3D widgets that we're going to drag into the scene afterwards, the components. And then we want to have a text. So this text is going to be where we display our key code. So when we press the button, it's going to display in there. And I have this one set to fill, center, actually stretched, and then center. And then make sure justification is centered as well. And I have this set right up to about 75. So it's pretty big. We see that's in the center. What we're going to do now is we're going to add a grid. So uniform grid, we're going to add that to our vertical box. So it's essentially below. Change this to fill. And what we can do now is we can start bringing in those buttons that we created as an instance. So WBP, digital keypad button. Bring this in and you see that's got our number. And because we made it a public variable, we should be able to go in and change that number. Did I not do that? So widget blueprint, I did not change display number to public. So we do that and then we go back to keypad. You can see that we've got display number here. So I'm going to set this to full. And then it's a case of literally going through and duplicating this 10 times. So button underscore or 1, I'm going to name that. So when we duplicate it, hopefully it does not do underscore or 2. So we're going to do this and then we can click the arrows to position them where we want. So you see this is going to be 1 and then 2. Duplicate, move over, 3. And then literally just keep doing this all the way through till we've got all 10 digits, which is tedious, but it's a lot easier to work with. So I'm going to pause this and I'll be right back. Excellent. So there we go. We've got all the numbers in. I've renamed them so they're appropriate so we know which one's which. And then what we're going to do is we're going to select all of these using Shift and we're going to make these full screen. So you can see that we fill up the space. And then for uniform grid, what I typically do is for padding, do about 15. And then after doing the padding for the top, so this goes around the borders, what we want to do is select slot padding. And this will do individual buttons. So I'll do something about 15 or 10. That's looking good. We can then scale down the vertical box if we want to make the size look a little bit more reasonable. For the text block, set center, just double check everything that looks good. And that's it for UMG really. We're going to go to the event graph in a minute, but before we do, what I want to do is go to our content browser and create another actor that we can store this inside of. So blueprint class, active, BP underscore digital keypad. And then in here, we're going to open this up and add a widget component. And I'm just going to make it the default scene root. And for the widget class, we want our keypad. So widget blueprint keypad. Draw a desired size. Should be good. And the text, that will be changed as well. So hit compile. And now when we drag it into the level, it'll be absolutely huge, but I'm going to set this 2.1, 1.1. And I'm going to rotate this around 180 to be our keypad. So again, position it, have it where we want. And just to sort the text out for the buttons, you'd find that if you press simulate, it'll actually update to what you want. But for now, we'll just set the default text in our digital keypad button. And then we can just remove this. And then we can also make sure that in our graph, the display number is set to 0, display number 0, and then it is in designer, should also be 0. Cool. And by doing that, I'm going to BP digital keyboard. It actually refreshes so we don't see the numbers, which is exactly what we're after. So now that it's in our level, we could actually press play. We could go up and we can actually click on these. We don't have anything happening with them, but we can press on them, which is what we're after. What we're going to do here is actually set up our checking code inside of this blueprint. So in the event graph. So we're going to go to our graph, and then we want to make sure we can access as much as possible. And from here, we're going to delete event tick and pre-construct. And we're actually going to select every single one of our variables, or we might have to do it individually, but we're going to drag those in. And just to start, we'll drag 0 in. And what we're going to do is we're going to do a sign, and then we can call that event dispatcher we created in that button called button pressed. And you'll see it has a button number. So button pressed event, that's fine. What we're going to do is we're going to bring in all of these buttons and we're going to connect it to this event dispatcher. So again, a little bit tedious, but once this is done, it's done and it works just fine. So once this is done, I'm finished putting them in, I will come right back. And now we can actually test to make sure this info is coming through properly. So we're going to do print string. We can connect that to our button number. And if we compile, so I've put all those in, that's all we need. We can drag this in. So now every time I press a button, you can see in the top left, it actually tells us what button has been pressed. So we're using the event dispatcher from one button, which is the key. It goes through our event dispatcher and we just tell that number which one to display. And then our interface or event dispatcher is listening to it here. So this is where most of our code is going to happen from, is along this bottom part. And then we will do a little bit at the top, just so I can show you how to make something that looks a little bit nicer than having zero text. So the first thing we need to do is create a string variable. And this is going to be called current code. So this is the one that they're entering in. It's going to be a string. We are going to have to do some conversions between string, ints, floats, and text, I think it is. Just double checking. But that's the one that we need for now. We're going to drag this in. We're going to get, delete those print strings. And what we're going to do is we're going to append our button number. Because we're appending it, we need to immediately set it. So we do a set and plug that in. And what this is doing is it's adding the current button pressed to our current code. So if we were to feed in just a button number, if the value went above 1,000, as in 1000, it would automatically add a comma to the text box that we're using. So what we need to do is we need to set up a little bit of code to remove that comma for us. And we're going to do that by getting the current code and then just do replace and from comma to blank, ignore. And then we're going to set our text code, which is what we put at the top of our widget here. So this is what we're going to set. So right now, this is going to be our code display. And then we want to make sure this is a variable. So again, we can access it from our event graph, which we're going to do by dragging this in now. So we're going to set text, brackets text, and then plug that into the return value and connect that like so. So this section removes comma from our number. So what we're going to do now is we're going to get a branch node and we're going to check to see if the length of the code being put in is the correct length for the code that we've been given. So this will make more sense once you see it in action. And from the append, we're going to drag up and we'll search len, and this will give us the length of the string. So if the code that we've given the player is 3 digits long, this will tell us that length is 3 digits, although we do need to add some on the accepted code. But it basically gives us the length of it so we can tell this what to do. From here, I do an equal, and then plug the output bool from that into our branch. And now we're going to set this bottom portion. To do this, we need a variable called accepted code. So we need to tell this UMG what the code is that it requires to activate. So we're going to do accepted code. So this is typically set by the developer. And we're going to have this as an integer. Let me double check. As an integer. And then we're going to bring this in. We're going to convert this to a string. And then we're also going to do len. And what this does is it gives us a number that starts from 0. So it counts up. So let's say if the code is 5, we'd have to put in 6, and it gets a little bit confusing. So what I did was I did a plus, and I just add 1 to the end, and then plug that into the equals. So now what we're doing is checking the length of the code to the length of the accepted one to make sure that once it says, let's say we put all 5 digits in, then it will check to see if it's correct. And that's what this is doing here. So we're essentially checking to see if the number of digits match the code that we put in. But what we wanted to make sure is that this isn't actually checking the numbers between each other. So that's what we're going to do next. To do that, we're going to get another branch. And from the condition, we want to do an equals. So equal operator. And what we're going to do is we're going to compare the current code to our accepted code. So, or our accepted code to current code. Like so. Plug those in. And it's going to do it for us. So now, if our code is correct, we can fire another dispatcher. So we're going to do event dispatcher, correct code entered, and then we'll do incorrect entered. So now you can actually have it tell the other blueprint what to do. So corrected code entered, we're going to say true. So we're going to call that. And then for false, what I find is the best to do is we're going to do a short delay, let's say of a second, where you could actually play a sound effect, just like incorrect message setup. And what we want to do is we want to reset the text for the numbers. So I want to put mine back to just dashes. So what we're going to do is we're going to have a new variable. I'm going to call this default text. So this is the text that shows up on the lock when no digits have been entered. And this is going to be a text variable. Drag this in, we're going to get, and then we're going to get our code display and set the text. Excellent. Plug those in like so. Then we're going to reset our current code to nothing. So we have no stuff in there because the code's been reset. And then we can call that incorrect code dispatcher. Call. So what we're doing is we're checking to see if this corrected code is correct. So check if accepted code matches the current code. And then if so, we've got true, and then we've got the false line. Before we go to the actual blueprint itself and we start looking at receiving information from these dispatchers, what we want to do is we want to do a little bit more coding up here. So on construct, we're going to set the default text for our code to what we want. To do this, we're going to get our accepted code, convert to string, and then we're going to do a len again. String length, and this time we're going to loop through it. So for loop, make sure that length is in the last index, and for the first index we want to add to 1. Cool. So what we're doing essentially here is, I don't know how long you want your code to be, your passcode for your game. So we've built this so it can be any length, and then this will loop through that and add a dash for each digit that's in there. So this way you're not building a widget for, let's say, a 3-digit passcode. This will work for any digit number that you want passcode length. So to do that, we're going to do default text, get to string, and then we're going to append. And then in this case, I want my padlock or digital display to just be dash, 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 dash. So that would represent 4. So I'm just going to add 1 dash. So we loop through it and we add this in. And we're going to set our default text back to it. So loop body to string. And now when we start, it will check the length of the accepted code. So what you as a developer tell the player that it needs to be. So let's say if it was 1, 2, 3, 4, that will be a length of 4. And it will put 4 dashes in there for you. And now it's a case of just setting the text. So get code display. Set text, plug this in like so. So this is essentially checking the length, checking length of our code, then adding symbols Cool, that should be all right. So I'm going to hit compile. And now we can actually go to our blueprint to tell it what our accepted code is. So if we go to BP Digital Keypad, we can go to our event graph. In here, what we're going to do is from begin play, we're going to get a reference to our widget, get user widget object. We're going to cast to the keypad. So keypad on begin play. This way we can get a reference to it. So I'm going to promote to a variable. You don't actually have to do that here, but you might want to if you're using it for something else. And then we can actually search for a sign, and you'll see that we've got a sign corrected code, or a sign correct code ended, and a sign incorrect code ended. We're going to do correct code. And then what we could actually do is have a sign incorrect code ended just afterwards. So these are essentially listening to the widget. So now we can have as many of these blueprints scattered around, and the instance for each one will be referenced to that blueprint. And now that we've got this, what we're going to do is we're going to set that accepted code. So if we drag off our reference and do search accepted, we can do set accepted code, plug that in between here, and then promote that accepted code to a reference or to a variable, and then it can have this exact same name. But what we want to do is we want to make sure this is public. So we can set it and then do compile. And let's do something like a print string to say correct code and then incorrect. So now if we go to our level, we've already got it in the scene. You can see that our accepted code on the right here, we can set this to be whatever we want. In this case, we'll do 2, 3, 4, keep it simple with 4 digits. So now if we press play, you see at the top, we've got 4 little dashes. And then I can enter these in and it will actually show up on the screen. And then after half a second, if it's incorrect, it says incorrect code in the top left, and then actually gives us the wrong one and resets the display. Cool. So now if we do 1, 2, 3, 4, you see it says in the top left correct code. It's then locked the number, it hasn't reset it, but you can see that we can actually keep adding numbers to it. So this is the next step, is we want to remove this. We're going to do that by going back to our keypad, so widget blueprint keypad, and all we have to do is do a branch from our button pressed from false to current code, and then promote the condition to true, and then disable buttons. Cool. So if the code is successful, we set this to true, and we just double check to make sure that this Boolean by default, which it wouldn't be, is set to false. So now if we go through, do the exact same thing, set this to full screen, and then we can go up. I can enter whatever number we want, and it's doing it faster because I don't stop it straight away. And then we can go through and do 1, 2, 3, 4 correct code. And now I can't actually input anything else. And what we could see there is if I'm fast enough and I do the incorrect code, I can just add more before it resets. So in BP Keypad, what we could do is say set code to false, actually set code to true. So we disable the input as soon as it's achieved. And then after that 1 second delay, we then set it back to false. So disable the button, redo it. So now we press start. I should be able to spam that. It stops at 4, and then I can go back in and re-enter the code. So for the dashes, if we go, let's say we do 1, 2, 3, 4, 5, 6, that's now 6 digits. As soon as we press play, you'll see that the code on the text at the top has 6 dashes. So this way we can actually tell the player how many digits they need, and we can have it reusable. So we can have multiple blueprints, and each one's going to be its own different thing, which is super handy if you want to reuse it anyway. So now that we've done that and they've disappeared, they'll probably show up in a minute. What we can do is we could set up in our BP Digital Keypad a blueprint interface. So for this example, what we can do is we'll do a blueprint class. We'll do an actor BP underscore code accepted, and we'll give this a cube. And essentially all we're going to do is we're going to give it an interface and say change the material to green. Blueprints, blueprint interface, BPI underscore keypad. And then if we open this up, we can do P-code. And that's all we need. So now in BP code accepted, if we go to class settings, we add an interface, BPI keypad. We can hit compile and you'll see that we've got key code reference on the left. So we search event, key code, and now we can make this do what we want. So we know we're just going to pass in the true, or what we could do is get the cube and set material, and then if it goes through, we could have a true. So set this to green, and then in our digital keypad, we just need to message that blueprint. So we're going to create a variables called actor, because it could be anything. And then make sure its object type is also actor with an object reference. Drag this in, make sure it's public so we can select it in the editor. And then we do key code message. Excellent. So from there, that information gets passed through. But if we do a Boolean inside of our blueprint interface, so interfaces is correct, we can now go back to our digital keyboard, select this to our incorrect, and for is correct, we'll set this to true. So now in our code accepted blueprint, we could have a branch that says if it's true, it means we got the right code. We set this to green. And if it's false, which means incorrect, we set this to red. Then we delay a second, and then we set it back to the default color. In this case, it would be basic shape material. Basic shape material, make sure the target is also cube. Excellent. So now, if we find these, I don't know why it keeps hiding them from me. What we can do is bring in this code accepted blueprint, like 1.1. We'll tell this keypad that we're going to talk to this blueprint, and this keypad is going to talk to this blueprint. So now we can set these codes up. So we'll keep this as 1, 2, 3, 4, and then the second one will be 7, 8, 9, 4. So we press play, we can actually jump in, go full screen mode, and then if we enter the wrong code, it goes red and then resets back to default. And if we do the correct code, it goes to green, and then that we're done. And then we can do the same thing here. We can fire in the numbers that we want until we do the correct code, which I can't remember what it was. 7, 8, was it 7, 8, 9, 4? Let's try that. There we go. So yeah, so that is how you can take something and make it a little bit easier to work with. So we do have a few blueprints, but they're quite basic to what they are. So we've got a digital keypad button, which is an instance that we're used for our keypad. And what this allows us to do is, if we want to redesign our keypad and we want something to look different, we could actually take these, rounded box, fixed radius, do half height, and then do 2020, 2020. I think it'll be that one. And then make it gray. We can increase this so we can make some nice results. And then I'm just going to copy this to all of them. That way it looks normal. Do the same thing for the corner radius. Paste. And then let's say 25. Copy. And we want to do the same thing for our color. And what that does is it means rather than having to go through and change 10 different buttons inside of our digital keypad, so inside of here, having to redesign them, you see that we broke it. But what you can do is you can modify one and then it'll update all. So that is just because my scaling was way too high, I think, especially for the size that I've put in. Keypad. Yeah, it kind of works. But you can see how we can go through and modifying one button does all of them. And it makes life just a little bit easier to go through. And then we can also do the same thing for the text. Color. And then make that larger. So you can see how playing around with this, it can make life just a little bit easier to work with. And then you can do what you want with them. So hopefully this helps you out. If you want to get access to these download files, you'll be able to head over to Patreon, and I'll have them up there after this. And then if you need any help with anything, make sure to head over to the Discord. Like it is, someone asked for help for this, and this is where we got the tutorial from. So it's super helpful. And if you want to support everything, yeah, just check out the Patreon. It'll be super awesome. Make sure to like and subscribe as well as everything else. I'm going to go, and then I'll leave you to it. Bye.